Okay. Mine is on free chlorine. I'm gonna mess that up a couple times. Free chlorine. Okay. So free chlorine is used as a disinfectant. It disinfects drinking water and swimming water. It doesn't take a lot of chlorine. It takes an actual like 0.5 milligrams per liter is necessary to properly disinfect it. But the problem with that is, I'll talk about that in one of the other slides. And the main thing it's used for is it prevents like deadly diseases that can be obtained through drinking non-disinfected water. And the main viruses known to infect people through water are typhoid and cholera in like third world countries and stuff like that.
Cholera.
Cholera, yes. Cholera. Okay, the source of the free chlorine, some water filtration systems implement the chlorine into the water. So when the water's going through the filtration, it'll obtain the free chlorine. And there's the two types of free chlorine that you're going to look at, the free and the combined chlorine. The free chlorine is what is left over after the combined chlorine has gone through the water and bonded with the various chemicals that it needs to. I know one of them is ammonia and another one's nitrogen. So once the chlorine has gone through the water and bonded with them, then there's all the free chlorine that's left over, and that's what we're looking at. Because that is the possibly deadly part. If there's too much free chlorine in the water, then it could be harmful. And it's toxic because even at small amounts, it's toxic to fish and other organisms in water. And the trihalomethanes are like carcinogens, and that's what comes from when the combined chlorine, which is also deadly, when it combines with nitrogen and stuff like that, the organic matter and the chlorine form the THMs. And testing for it, since chlorine is used in pools and all that, it's a very mainstream kind of water cleaning tool. So there's a lot of different tests that you can use. You can get the pool test, the color test, the colorimeters, and they all have their pros and cons to them. So what we probably used was the pool test kits because they're just cheaper and we can get them. Like the little strips that you use to put in water, and then the strip changes color and you match it up with the concentration of chlorine that it shows. And then removing it, dechlorination, there are three main methods. The absorption activated by carbon, it's a 1:6 ratio, so 1 pound of activated carbon to 6 pounds of the chlorine. The chemical, which you're going to use sulfites, bisulfites, or meta-bisulfites in a reduction reaction, which will also take out the chlorine, and the ultraviolet light, which the free chlorines and chloramines, when exposed to the ultraviolet light, will turn into hydrochloric acid. And then there are my sources.
Dylan?
Yeah.
What's the source of, can you give us the source one more time of where free chlorine is coming from?
From like, well, if it's like a pool, you're getting the free chlorine from chlorine tablets, which are put in the pool in the water filtration.
Okay. What about, like, around here, a real big issue is going to be the use of different fertilizers and such running off and going into rivers, creeks like Coon Creek, or getting right into our tap water like our groundwater. Would that be a free chlorine be an issue because of farming?
Yeah, it could be if there's too much fertilizer being used, then it could definitely get into the water systems and then cause a problem to like the aquatic life.
Okay. You guys should be asking these questions too, because remember what we're doing is you have an opportunity of not having to do each of these individually, but now you get to hear a quick, brief synopsis from Dylan and from Tyler. Each of you guys get to hear from somebody else. So make sure you're getting all the information here you need, like the sources. And really, why is it bad? Maybe, Dylan, can you run through that one more time with us? Why is this bad? Is too much chlorine harmful to people, or just the living things inside the water systems?
It's harmful to both people and water systems because too much chlorine could be very dangerous to your health. Like It could cause cancer, like a lot of different chemicals, and yeah, it honestly doesn't take a lot of chlorine to cause something bad like that. And since the safe amount of chlorine is so low, and they try and keep it below, I think it's 0.3 parts per million in most water, because above that, people can smell it, they can taste it, they really complain about it. So that's really what they aim for, to keep it below 0.3 parts per million.
Okay. And actually, that's really, I'm sorry, go ahead, Colin.
It's only harmful when there's like an abundance of it, like you're exposed to it in little amounts, but like over time, like if someone has a pool, for instance, they have a low amount, but they're in it a lot, that's not harmful compared to as if you just put too much in the pool.
Not necessarily like drinking at that level.
Yeah, like in pools, there's a decent amount of chlorine, because you can usually smell it, and if you've ever drank pool water, you know it does not taste good with the chlorine in it. So in pools, it's not like a deadly amount, but you definitely don't want to be drinking it.
Well, who's going on spring break next week? Where are you going, Adam?
Gulf Shores, Alabama.
Great. You're going to drink water with chlorine in it, aren't you? Not on purpose. You're not filling up a glass. But when you go swimming, you're going to be swimming in water full of chlorine. Salt water with NaCl is naturally going to have chlorine ions. Really what it does, though, is it helps clean. It helps get rid of bacteria. The problem is you don't want too much that it then starts to mess with your biological system.
Yeah, because I was going to say, isn't it like what people have to do if they can't get like a vet, if like their dog's infected with something, they give it like a little bit of chlorine?
You know, I don't know about that. You might be right. I just don't know. But it's like anything. For instance, last chapter you were reading about, or no, maybe this chapter you were reading about too many nitrates and phosphates. How about when we fertilize, our fertilizers are full of nitrates and phosphates. But too much actually hurts the plants. It's the same idea. A little bit of the free chlorine is good, but too much can lead to serious health risks, especially in humans. One more thing, Dylan, before we let you go. This is what we as a class really want to focus in on. What are the free chlorine ranges that we want to, what's the free chlorine range for clean drinking water? Now, so here's really going forward, guys. We're going to have different layers of water, not layers, levels. We're going to have clean drinking water. We're going to have water that's maybe not necessarily drinkable, but we can wash our dishes, we can bathe in, etc. We've got water that we would only maybe let our dogs swim in, okay? We've got, like for instance, I'm thinking of at Michigan State, the Red Cedar River. I'd let my dog swim in it, but I wouldn't swim in it. We've got water like a step below that is just nasty, right? And then we've got completely diseased, polluted water. So there's kind of like 5 levels of water. Do you have the different ranges of that?
I don't, but I know I looked at a table of it in comparison to how dangerous they are to like aquatic animals, and I remember that above 1 milligram per liter is dangerous to all aquatic life, and then like around or below or equal to 0.8 milligrams per liter is dangerous to oysters, which oysters are like the toughest of them when it comes to the chemicals. And then I think it's around 0.7 or 0.6 is when even like the toughest of the fish start to die off. Okay. It's 0.6 milligrams per liter.
So can you say, so above 1 milligram per liter?
Yeah. Like 1 milligram per liter and above is dangerous to all aquatic life.
And then you said like 0.6 to 0.8 is dangerous to some?
It's dangerous to like most. And then below that is some of them.
So what would drinking water be?
Drinking water would be probably below 0.5. Definitely below 0.5 actually. Because at 0.5 you can start to smell it and taste it. So.
Is this something you know, Dylan, or is this something you're guessing?
This is I looked at a table of it.
And you're remembering this exactly, or is this something that you need to double check before you give us the wrong information?
I'm talking about the parts that I remember exactly.
Okay. So what we're really curious about though as a group is the drinking water levels. Because we want to be able to test for drinking water. That's you're pretty confident that 0.5 is below 0.5 is accurate?
Didn't you say something about it being like 0.3 or?
Yeah, well, 0.3 parts per million
Uh-huh.
of the chlorine, that's definite, I'm 100% sure that's when you can start smelling and tasting it. So you want it below 0.3 parts per million.
Okay.
But I wanted to keep a consistent unit with the milligrams per liter.
Okay. All right, thanks, Dylan. Anything else, guys? All right, next.